In this video, we're going to be discussing binomial radical expressions and how to add, subtract, and multiply them. So adding and subtracting radicals, you only can add or subtract radicals that have the same index and the same radicand. So for example, this index are both a 2, they're both square roots, and the radicand, the number or variable underneath the square root, is also the same. So 5 minus 3 would give you, in this case, 2 square roots of x. You basically are just combining the coefficients in front. So in this case, they're all square roots. However, they do not have the same number on the inside. So at first glance, you would say you cannot simplify. But however, you possibly can because you can reduce. So the square root of 8 is 4 times 2 because you got to come up with perfect squares to get to that. The square root of 18 is 9 times 2. You cannot use 6 times 3 because neither of those are perfect squares. It has to be a perfect square. And the square root of 32 is 16 times 2. Now, if you notice, they all have actually a 2 in common, which is great. So I'm going to combine. The square root of 4 is 2. So 2 times 3 will give me 6 from here. The square root of 9 is 3. 3 times 5 will give me 15. And then the square root of 16 is 4, and you're left with the square root of 2. Now that all of your radicands are the same number, now you can combine your coefficients. 6 plus 15 is 21, and 21 minus 4 is 17 square roots of 2. Now, let's see if we can add or subtract after we have simplified. So for example, this has a square root of xy. This has a square root of xy. This does not. However, we can simplify by dividing by the index. This is a square root, so if you think of that as a 2, 2 goes into 3 one time, and there is one x left over and then this y left over. So now we all have the same radicand underneath the square root, so we can combine 4x's minus 2x's are 2x plus another x, so you will get 3x of the square root of x. Y would be your final answer. Same thing here. First, you have to see, is there anything that can be combined, or in this case, simplified? So you have the square root of 7. Now, is there a perfect square that goes into 14? No, there is not. So you cannot simplify square root of 14 down. But the square root of 28, you can reduce. 4 times 7 will give you the square root of 28. Square root of 4 is 2, and 2 times 6 is 12. So we can at least combine this 2 square roots of 7 and this negative 12 square roots of 7. 2 and negative 12 will give me a negative 10 square roots of 7. And then we're just going to bring over the 5 square roots of 14, and you are done. Again, when adding and subtracting, you cannot add the radicands underneath. You can only combine the coefficients in front. Do not add 7 and 14 to give you the square root of 21. You cannot do that. You can only combine when multiplying. Now this, you have a cube root of 24 and a cube root of 81. They are not the same radicand, but you can check and see if there's anything in common. So a perfect cube that goes into 24 is 8, and 8 times 3 will give you 24. And a perfect cube that goes into to 81 is 27 times 3. So the cube root of 8 is 2 with cube root of 3 left over. The cube root of 27 is 3, and 3 times 2 is 6 with a cube root of 3 left over. Now that you have the same cube root and the same radicand, you can combine the coefficients. So 2 and a negative 6 will give me a negative 4 cube root of 3 for your final answer. Now, multiplying, you can combine numbers that are inside of the square root. As long as they're both cube root or they're both square root, you can combine to multiply them. So when you distribute, square root of 5 times square root of 2 is the square root of 10. And then whenever you distribute again, you only multiply square roots with square roots. So the 3 stays out front, and square root of 5 times square root of 5 is the square root of 25. Now you would be done, except check to see if anything can be simplified, which it can. The square root of 25 is the number 5. So your answer is the square root of 10 plus 15, because the square root of 25 is 5, and 5 times 3 is 15. Next, you would have to FOIL this. So square root of 2 times 3 square roots of 2 would be 3 square roots of 4. Square root of 2 times 4 square roots of 5 would be 4 square roots of 10. Remember, you can only multiply square roots with square roots, so 2 times 5 would be 10. And then FOIL this next one. Square root of 5 times this would be a negative 3 square root of 10. And then square root of 5 times 4 square roots of 5 would be a negative 4 square roots of 25. Now see if there's anything that can be combined and reduced. For example, the square root of 4 is the number 2. So 2 times 3 is going to give me 6. Also, same thing here. The square root of 25 is 5. 5 times 4 is 20. And then these two can combine because they have the same square root and the same radicand. So you can combine the coefficients. 4 and negative 3 will give me a 1 square root of 10. You still have these two whole numbers, 6 and negative 20, which will give you a negative 14. And then you have a plus square root of 10 as well. We have discussed in the past about rationalizing the denominator to where you have to get the square root of the denominator out. You're going to do the exact same thing. So the square root of 6, we are going to multiply the bottom and top by the square root of 6. So on bottom, we'll be left with 6. The square roots cancel basically. And then we will have to distribute this square root of 6 times the binomial. So 4 times the square root of 6 plus the square root of 30, because square root of 5 times square root of 6 is the square root of 30. And there is not a perfect square that goes into 30, so that would be your final answer. You cannot reduce 4 and 6 because there's nothing on this second square root in front that would also be able to reduce. So you either reduce every part or you can't reduce at all. Now in this case, does anyone remember when we discussed conjugates in the past? So we are going to multiply by its conjugate. 5 minus the square root of 2. The conjugate is 5 plus the square root of 2. You only change the sign in the middle. So we're going to multiply the top and bottom by 5 plus the square root of 2. 7 times 5 is 35, and 7 times the square root of 2 is 7 square roots of 2. You cannot combine these because that has a square root, that does not. On bottom, you will have to FOIL. 5 times 5 is 25. 5 times the square root of 2 is 5 square roots of 2. Square root of 2 times 5 is a negative 5 square roots of 2. And negative square root of 2 times square root of 2 is a negative square root of 4. The two middle terms cancel. That's what they're supposed to do. And if they don't, we did something wrong. So we are left with 35 plus 7 square roots of 2 on top. And on bottom, the square root of 4 is the number 2. So 25 minus 2 will give me 23. And we were able to rationalize the denominator, and we no longer have a square root in the denominator because we used the conjugate. So I would like for you to pause the video at this point, try to work through these problems on your own, and then resume to see the answers. Okay, for the first one, I need to reduce. The square root of 45 will give me 9 times 5x. I cannot reduce this next one, but the third one, I also can simplify into 4 times 5x. And I notice that, they all have a 5x in the square root. So the square root of 9 is 3. 3 times 6 is 18. You cannot reduce that, so I'm just going to bring it down. And the square root of 4 is 2. 2 times 4 give me 8. Now I notice they all have the same square root and they all have the same radicand, so I can combine the coefficients in front. 18 minus 3 is 15. 15 plus 8 will give me 23 square roots of 5x. This square does not mean that you just square the 4 and then you just square this. You do not do that. Do not. This means that you literally are going to write this binomial twice. And now you get to FOIL. 4 times 4 is 16. 4 times 3 square roots of 5 is 12 square roots of 5. This will give me another 12 square roots of 5. And then 3 square roots of 5 times 3 square roots of 5 will give me 9 square roots of 25, because 3 times 3 is 9, 5 times 5 is 25. The two middle will combine to give you 24 square roots of 5. Square root of 25 is 5. 5 times 9 is 45. So this 16 and this 45 you can combine to give you 61, and then you have 24 square roots of 5 left over. In this next one, we need to rationalize. So we are going to multiply by exactly what it is. There's no conjugate. We only do that when there's a binomial. So on top, we are going to distribute. So we should get 2 square roots of 5x plus the square root of 5x squared. I'm going to put a little note there because that can be reduced. And then on bottom, square root of 5x times square root of 5x, the square roots cancel, leaving me 5x. So normally we'd be done except this x squared, the index can divide into it. So we'll be left with 2 square roots of 5x plus x square roots of 5 over 5x. In this last one, you will need to write the conjugate down, which is 1 minus the square root of 7, and you will need to FOIL both the numerator and the denominator. So for the numerator, 3 times 1 is 3. 3 times the square root of 7. 2 square roots of 5. And then 2 square root of 5 times square root of 7 is going to be a negative 2 square roots of 35. And then in the denominator, 1 times 1 is 1, minus the square root of 7 plus the square root of 7, and then minus the square root of 49. Now in the top, nothing combines at all. So you will just have to write the entire numerator next to each other because you cannot combine any of those. And then on bottom, the two middle cancel, which are supposed to, and the square root of 49 is the number 7, and 1 minus 7 is negative 6, and that will be your final answer.